Hi, my name's Charlie McCann, and today I'm going to be talking about geometry and how it relates to aerospace engineering. Geometry is a massive subset of the mathematic discipline, concerned primarily with the study of spaces, shapes, and volumes. These subjects make up the primacy of what is known as Euclidean geometry. In addition to this is non-Euclidean geometry, which arose much later and covers much more abstract geometric questions. There are a multitude of geometric discoveries which must be understood when dealing with the subject of aerospace engineering. Perhaps the most immediately obvious is the shape of the airplane. In the approximately 100 years that humankind has engaged in aerospace travel, there has been much experimentation with the size and basic design of airplanes, yet the fundamental shape of the plane has remained largely unchanged. In a typical airplane design, the fuselage is a long, narrow shape that grades into a cone on the front of the plane. This is done to lower wind resistance and maximize the speed with which the plane can move through the air. Wing design too is almost uniform among airplanes, jutting out of the middle of the fuselage on each side of the plane and sweeping backwards. The shape of the wing will almost always be raised on the top and flat underneath. This wing shape is important to maximize lift. In these simple designs, the geometric fields of shape and space are manipulated to produce the optimal flight capabilities of the craft. Another important geometric bearing on aerospace design is the takeoff. Almost all planes, except a few very sophisticated military aircraft, will take off after generating quite considerable speed while landing. For these planes, wheels are lowered from the fuselage and the plane will drive on them until reaching a speed of around 250 kilometers an hour. For this purpose, too, geometrics is involved. The shape of the wheels are obviously integral to the takeoff function. Anything other than a perfect circular shape, and the plane would be unable to take off and thus fly. The shape of the runway, too, must be perfect, perfectly flat to maximize speed generation and safety during the takeoff phase. This process also incorporates space into the proceeding, as the plane moves along the runway. The concept of space is also obviously present when dealing with the flight of the plane. In a typical civilian flight, the plane will start on a runway, fly upwards in the air until it reaches a cruising altitude of around 9,200 meters, and then remain at that altitude until it descends onto another runway. This altitude is selected as the air is much thinner at this height, which reduces wind drag, maximizes speed, and thus lower the costs of the flight. If imagined this way, the flight path resembles an upside-down parabola with an extremely lengthened vertex. This act of mapping the angle an object takes through the space is one example of non-Euclidean geometry. Since its inception in the early 20th century, aerospace technology has had a revolutionary effect on almost all facets of global life. It has achieved a complete upheaval in the domain of civilian travel, granting the ability to travel from one point on the globe to another in a speed previously considered unthinkable. This in turn has demystified much of the world, and along with incredible recent strides in telecommunications, ushered in a global era of dialogue and fraternity hitherto thought impossible. Both the arenas of work and leisure have seen complete upheavals in its wake, with companies able to utilize the labor of talented workers from any point on the globe, and the list of possible holiday destinations greatly widened. Yet the effects of aircraft have not always been for unequivocal good, with the technology arguably having a greater effect as a military application than any other invention thus far. Today, all major military powers have very advanced air forces fleeted by a multitude of sophisticated fighter and reconnaissance aircraft. Considering the magnitude of the damage wrought by aircraft bombing campaigns, it is clear that man's mastery and application of geometric precepts can have a cataclysmic effect on the world at large. I've also done a mind map to link the concept of aircraft technology to various STEM pursuits. Science, technology, engineering, and mathematics are all present. Cool. Thank you very much. My name's Charlie McCann, and thank you for watching this speech.